All right, page 750 today, we got special segments in a circle. All right, theorem 10.15, segments of chords theorem. If two chords intersect in a circle, then the products of the chord segments are equal. So we've got a circle here, and then two chords that intersect inside the circle. If we label these A, B, C, D, E, and AB is 5, BC is 12, EB is X, and B to D is 10. We've got two chords intersecting in a circle, the products of the chord segments. So what that means is that this segment AB times segment BC. So we take 5 times 12, and we set it equal to EB, which is X, times BD, which is 10. All right? The segments of each chord, the product of the segments of each chord are equal. So 5 times 12 is 60, is equal to 10x. Divide both sides by 10. And 6 is equal to x. AB times BC is equal to DB times BE. All right, so look at example 1b, just below that. Again, a circle. Two chords intersecting inside the circle. Got a P, K, and an M, and then a J and an L. And P to K is x plus 1. K to M is x plus 8. JK is x plus 10. And K to L is equal to x. So we're going to multiply. So we're going to take this x plus 10 times x, and that's going to be equal to x plus 1 times x plus 8. In this case, on the left-hand side, we got to do the distributive property, so we're going to multiply the x times the x, and we're going to get an x squared. and then the x times the 10 would be positive 10x. And then we're multiplying on the right-hand side a binomial times a binomial. So we have to do the distributive property twice. And x times x is x squared. And then x times 8 is positive 8x. We got 1 times x, which is positive x. And then 1 times 8, which is positive 8. Next step is to combine the 8x and the x in the middle of this equation, or in the middle of this product. So on the left-hand side, we've still got our x squared plus 10x. On the right-hand side, we have x squared plus 9x plus 8. So when we've got an x squared on the left-hand side and an x squared on the right-hand side, you can cancel those out. Can you hold up on the serial for a little bit till I'm done talking, please? These x squareds will cancel out. And then we can solve for x. So we're going to subtract 9x from each side. And 10x minus 9x is just x. And then our 8 falls down. Our x is equal to 8. All right, if you move on down and look at the guided practice 1B, we'll do that example as well. All right, so our W to S segment is x units long, and S to Y, or actually I put a T down there, S to T is going to be x plus 12. Z to S is x plus 6. And S to X is x plus 2. So again, the products of each chord, the products of the pieces of each chord, the products of the segments are equal. So on our first equation, or our first product, is going to be x times x plus 12. And that's going to be equal to x plus 6 times x plus 2. We're going to distribute on the left. So we get x squared plus 12x. On the right, we got to do the distributive property twice. So x times x is x squared. X times 2 is positive 2x. And then we've got the 6 times the x, and then the 6 times the 2. So 6 times x is 6x, and 6 times 2 is positive 12. You can cancel these x squares now if you want. And then in your next step, we'll bring down the 12x. We'll combine the like terms. The 2x and the 6x gives us 8x plus 12. You can subtract 8x from each side. $12x minus 8x, that gives us a 4x equal to the 12. And then divide both sides by 4. 4's cancel, and our x is equal to 3. Anybody have any questions on chords intersecting inside of a circle? All right, then your practice for today is going to start on page 753. Problems 1 and 2. And then 6 through 9 on the next page.